Hi, so today in this video we're going to be going over 1015, chapter 1.3, transformations and inverses of functions. So let's just hop right into it. When we're talking, I know I covered this in a previous video and you've listened to it in class, but when we are talking about the inverse of a function or the inverse of points, we're basically just flipping the x and the y. And then to add on to that, when we're talking about transformations, there are a few things to keep in note. So what we're looking at is we have stretching, compressing, shifting, and within shifting, shifting up, shifting down, shifting left, shifting right. And then we have reflection, and within reflections, we have reflecting over the y-axis and the x-axis. When we are talking about stretching, we are really only talking about the y value. So hold on, And what we want to do with it is multiply our y value. So actually, y times our y value times our stretch factor. And so if your stretch factor is 3, it will probably look something like 3x. What you're going to do basically is, so a normal x graph will look like this basically. So like 1, 2, 3, 4, 1, 2, 3, 4, where it's going up 1 over 1, up 1 over 1, and so on. But when we're stretching it by 3, we actually go up 3 over 1 instead. So we're basically doing something like this. We're multiplying all of our y values in our coordinates by 3. Even it's a little bit confusing because it says 3x, but we're basically saying we're going to see what point the y is when x would be at 3, but we're going to say that's where x is at 1. It's kind of confusing to put it in words like that, but just know that it's y times 3 when we're stretching. Conversely, compressing still messes with our y value, but instead it's actually y divided by our stretch value. So if it says something like compress our graph by 1/4, we're basically dividing by 4. Stretching and compressing actually is the exact same thing. We just use different, like the exact same process. We just use different language for what it's doing. So if you had a stretch value of 1/4, that's the same as having a compress value of 4. Hopefully that makes sense. They're basically the same thing. I prefer just talking about stretching and multiplying by 1/4, but that's okay. Compressing works too. It's the same thing, it's just with different language. And then shifting, when we're talking about shifting, we're talking about moving it around. So if we have a regular graph like this, and we'll just say, boop, we'll just say it's this. Shifting up would mean we're just moving this graph up a bit. Shifting down would mean we're just moving this graph down a bit. Shifting to the left means we're moving it to the left a bit. And shifting it to the right means we're moving it to the right a bit. When we're talking about what happens to the coordinates, when we're shifting up, we're basically keeping our x the same, but we're adding the value of our shift to our y value. And then conversely, when we're shifting down, it's the same except for we're minusing our shift value from our y value. And then when we're moving to the left, see it's this way, right? So we actually we're taking x and minusing it by our shift value. And then we're keeping our y the same. And conversely, when we're moving it to the right, we are adding our shift value to our x and keeping our y value the same. Now, reflecting over the y-axis is when you take your coordinate and you're actually going to turn all your x's into minus and keep your y's the same. Because see, if you're shifting over y-axis, you're basically just doing like this, right? But your x values are turned into negative. When you're shifting over your x-axis, you're doing the same but to the y value instead. So you're doing positive x, you're keeping your x's the same, and you are reversing all of your y's. You're going to subtract, you're going to make all your y's negative. Now, getting that over, and then real quickly, when we were talking about inverses, I think I mentioned this actually, we're just flipping x and y values. And we'll get into this when we start graphing. Now, this one is telling us to select the correct transformation from the original, which is the blue one, so it's this one, and I'll thicken it a bit. Select the correct transformation of the original blue graph has undergone to become the green graph. Sorry, that's weird wording, I think. So it looks like the green graph literally just moved up 1 unit. Bloop. So that would be your answer. And then the original turning graph of the blue, which is our vertex where it starts, is 0, 0. Now it's just moved to 0, 1. This is still our turning point. This is 0, 1, x, y. Yep, and that would be your answer. And you want to make sure that you have the parentheses around it and a comma in between. Now this one is the same question, but with a different graph. Select which transformation the original graph, blue, has undergone to become the green graph. It looks like it was moved over 4, moved to the left 4. So it was shifted left 4 units. Yes, so it'll be this one. And then the turning point, which is at 0, 0, now is -4, 0. Now we are trying to, so the original graph, blue, has been shifted to create a new graph. And now we want to give the coordinates of where point A has moved to. So we want to say, okay, where did this move to? And it looks like it moved up to 3, 3. You can tell because of the shape of the graph, this is where the turning point is, right? And then now we want to find where the B, what happened to the B. Now this is tricky because the B actually isn't on this graph anymore, on our green graph. But we know that we shifted up 3 and we shifted to the right 3. So we're going to say x plus 3, y plus 3 for our point, and then we'll plug in the point of B. So B is 3, 9. Our new point will be 3 plus 3, 9 plus 3, which turns into 6, 12. So our new, for B, it's going to be 6, 12. Hopefully that made sense. A point, 9, 6, lies on the graph of y equals f of x. If the graph is flipped across the x-axis, what is the coordinate of the point that 9, 6 becomes? Now this one, if you remember, when we're flipping across the x-axis, we're basically minusing our y values. So it's going to be 9, -6. I'm pretty sure. I think that's the format that you wanted it. And then this one says, use a graph of the function to sketch its inverse function. Now, these are really tricky, and there are 2 different approaches that I recommend. It's really hard to keep coordinate points in your head, and even harder to keep those coordinate points and then flip them and keep holding onto both. So what I would do is I would have a separate sheet of paper and mark down the coordinates. This coordinate is 1, 0, and this coordinate, you can choose any point. I like choosing the intercepts because they are easy to figure out, I think. So this one is -2, 0, -2. For the inverse, we're just going to flip them. So our new points are going to be 0, 1, and -2, 0. So 0, 1, and then -2, 0. So our new graph looks like this. Something like that. You just want to connect them. Yep, something like that. And what you'll do in Lumen is you'll put a point right here, and then you can drag it over to 1. And that is your answer. Again, you can pick any point on this graph, on this red graph. You could say, okay, I kind of want to know what this one is. That's going to be 3, 4. You would just flip that, and so now it's 4, 3. And the new point would be right here instead. And that, I think that works out, yeah, with what we were doing. That's the method that I recommend to you so you don't get things confused. What I would do if you have more familiarity with the subject is you say, okay, I know that we start at 1 here, so we're going to start at 1 here. so on our x-axis, we start at 1, 0. When we're inversing, we are flipping it to 0, 1. So our y-intercept is going to be that. And then our our new x-intercept is going to be the old y-intercept, so -2. And then you just do it quick. You don't have to write points down if you are familiar with it. But I recommend writing points down. This one is saying, the graph of a function, f of x, is first compressed to 1/5 of its original height, then shifted horizontally right by 3 units, and then shifted vertically up by 1 unit. Now, these get a little bit confusing, and I will, excuse me, I'll go over it. So, first, if you remember, so we have the point A, 8, 25. We are first going to shift it, we're going to compress it. So either you divide this by 5 or multiply by 1/5, which is exactly the same operation. So x, y, which is 25 divided by 5, that will give you 8, 5. And then we shift it horizontally right by 3 units. If you remember, we're adding 3 to our x value. So 8 plus 3, 5, and that will give you 11, 5, and then we shift it vertically up 1 unit, so that would be 11, 5 plus 1, and that will give you 11, 6. That is your new point. 11, 6, and you want parentheses around it. Now, the second part of the question is confusing if you aren't understanding of what it wants. So let me erase this. No, actually, we'll keep it. Let me just move it. So it's saying, what are the coordinates of a general point on the graph y equals f of x? It's exactly what we did, but instead of having numbers in, we will have it with x and y's. So for our x point, we know that the only thing that we did to our x was add 3 to it. So x plus 3. Then for our y point, we know that first we divided by 5. So y divided by 5. And then we added by 1. And that would be our coordinate point. So x plus 3, and then y over 5 plus 1. This one is the same kind of question, but I think it's good to go over it again. This one is stretched by a factor of 4. Real quick, I'm going to change this problem because I forgot to find an example of a problem that I saw earlier, that I helped a student with earlier today, that was kind of really confusing. That was weird. So I'm going to copy this and paste it. And I'm going to put it to the side real quick. And then, hold on. I'll just do it. Okay, so I've seen a problem like this where it says the graph of a function, f of x, is first shifted up vertically by 2 units, then shifted horizontally right by 4 units, and then stretched by a factor of 4. Now, you'll notice that the order is a little bit different. Here they said compressed first or stretched first, and here they're saying stretched last, and that will make a difference in what our general points are, but not in what our thing here is. So first, we have 6, 6, 6. We shift it up vertically by 2, so 6, 8. And then we are going to shift it horizontally by 4, right by 4. So 6 plus 4, 8. And this was 6 plus 2. And then that will give us 10, 8. And then we're going to stretch it by a factor of 4. So then we'll do 10, 8 times 4. That will give us 10, 32. And that's our new point. Now, where people go wrong is they say, oh, it's going to be exactly the same as last time. So we have x plus, 4? And then we have y times 4 plus 2. But if we did that with our points, we would get something different. We'd still have 10, but instead we would have 6 times 2, 12 plus 2, which is 14 instead. And the reason why that is because, so we still have our x plus 4. But in this case, what we did is we did y, we shifted up first, y plus 2 first. And then we multiplied that by 4. Sorry, what was it for? 4? Yeah, 4. And that turns into x plus 4, the x stays the same. And then 4 times y plus 8 instead. Now that's tricky. You got to keep an eye out for that because that throws people off a bit. So our general transformation will be x plus 4, and then it will be 4y plus 8. You got to distribute that 4 throughout the thing. Yes. I know this one got a little confusing near the end. If you have any questions, please let me know, and I will answer them as soon as possible. Have a good one.